Welcome back to school, guys. This is the first video you're probably watching, even though there was a day one video if you want to go back and review the stuff we talked about in class today. So, graphs of rational functions. There's things that happen with rational functions because of the domain restrictions that the domain restrictions make the graph either have holes or asymptotes. So, let's talk about what each one is. A hole is a point where the graph is undefined. So it's a point. And how do we get a hole? Well, if you get something that looks like this, well, let's just say we factored out our equation, and I might have talked about this in class today. You get something where you can cross out the top and the bottom term. If you can cross out the top and bottom term, so for example, in this case, x would equal -1 would be the x coordinate of the hole. That's not for everything. That's just for this example I made up on the side. So it's where you can cancel the numerator and denominator. And what happens on a graph is that when you have it on the graph, there's just a hole. It doesn't like jump. It's just a hole in the line. So the other one is an asymptote. Asymptotes are lines the graph approaches. But cannot be part of the solution. So, for example, if we look at this table here, it goes from 0, -0.8, -1 to error, so there's something here, and then -2 to -2.587. There's not a big jump here. In fact, this looks like this -1 is in line with these other two, so this is probably a hole. So you can check your calculator's table to kind of see that. Here, it's a different story. We go 4, -8, 5, there's an error, and then 6, 10. Okay, and notice how this is getting more and more negative. Then all of a sudden there's an error, and then all of a sudden we're at +10. This would be an asymptote. And it would be a vertical asymptote. Because most of these we'll talk about right now are vertical when we have denominator x's on the bottom, which are part of your domain restrictions. So just a quick thing of what this looks like on a graph. If I make a graph here, and I say there's a hole at -1, I don't know what the graph is, I'm just making one up, and let's say there's a vertical asymptote at 5. There's the asymptote, it won't cross that. With horizontals, though, it can cross it. We'll talk about that later. Horizontal, it's end behavior, really. So here's what the graph looks like, and then it jumps up here. Okay. So this would be a hole. This would be an asymptote. Okay, that's what they look like. So for each function, we're going to do all this stuff. Write an equation of any vertical asymptotes. Again, this comes from what's left on the bottom. So the non-canceling things, non-canceling domain restrictions. Okay. Horizontal asymptotes have 3 rules. If degree on top, so let's say it's x squared over x. Actually, let's say it's x over x squared. If degree on top is less than the degree on bottom, the horizontal asymptote is y equals 0. It's just 0. Which makes sense, because as the function gets more and more, as x gets bigger and bigger and bigger, so let's say x is like 100, and we have x on top and x squared on bottom, the bottom's going to get faster quicker, so it'll basically come up to be a fraction of 0. So this is number 1. Number 2, if the degree is the same on top and the bottom. If the degree is equal on top and bottom, then it's the ratio of the lead coefficients. So it would be like A over B. It's the fraction. And finally, if it's the third thing, 3. If it's top heavy, so if the degree on top is higher, there is no horizontal asymptote. You don't say equals 0, there's just none. Alright, so we got all the stuff down. Again, pause the screen if you need to. We're going to go over this again in class tomorrow too, just because this is very important, but it's good to go through it the first time. So for all these problems, we have to do all these parts. I always like to do step D first. Well, first of all, I like to simplify it. So the first thing you should be doing is factoring this. So I'm going to do that up here. Pull a negative 3 out. I get x squared minus 1 over x minus 1 and x minus 2. Okay, and then go one more, because you can factor the top with difference of 2 squares. And so x plus 1, x minus 1 over x minus 1, x minus 2. Okay, so before you cancel anything out, you look at the bottom. What makes this impossible? Well, you can never have a 0 on the bottom of a fraction. Well, what values make a 0 on the bottom of a fraction here? It would be 1 and 2. So for my domain, for part D, I'm going to say x is such that x can't be 1 and x cannot be 2. Okay? We cannot do the range. The range you do last, domain I like to do first. Range is the thing you look at the end with the graph. So, alright, so then for part A, write the equation of any vertical asymptotes. Well, first of all, let's simplify this one step further. Now that I have my domain, I cross these out. Those are a hole. So right away, part C, list any coordinates of the hole. There's a hole at x equals 1, and then we don't know the y value yet. We'll deal with that later. And what's left over? Well, the vertical asymptote is the domain restriction that's left over. So we already used x equals 1, so the vertical asymptote would be x equals 2. That's where it's undefined. As we look at our domain restrictions, we have now used x equals 1 and 2. 1 for the hole, 2 for the vertical asymptote. Now we have to finish the rest of this up. List the coordinates of, or write the equation of any horizontal asymptotes. That's where we have to look at these rules. Well, if you look at this, there's an x squared on top and an x squared on bottom. We look over here. If the degree equals on the top and bottom, it's the ratio of the lead coefficients. Well, my lead coefficients from the original are negative 3 over 1. So, my asymptote is negative 3 over 1. So my equation for that, since it's a horizontal line, is y equals negative 3. Okay? Now, to find the second coordinate of the hole, you do not just pick a number. You don't say 1, 0. You have to plug in this value, this x value, into the simplified form. So for holes, plug in into the simplified form, which is over here. Okay? So, if I plug in, I'm going to just do the work here. I get negative 3 times 1 plus 1 over 1 minus 2. So this is 2 times negative 3 is negative 6 over 1 minus 2 is negative 1. So we get 6. So the coordinate of this hole is 1, 6. Now, I have everything I need except for the range in the graph. Again, I like to look at the range at the very end. You should never fill out the range until the end, just because sometimes there's a restriction that changes it. And I'm going to graph this. I can do this without even looking at the calculator now, because I have pretty much everything. Although you can look at the calculator. We have a vertical asymptote at x equals 2, 1, 2. We have a horizontal asymptote at y equals negative 3, 1, 2, 3. So, here's a vertical asymptote. Here's the horizontal asymptote. We have a hole at 1, 6. So that's up here, somewhere right there. And that's about it. Now, and we also have an intercept when y is 0. What makes y 0? We can figure that out. Look at the top of your fraction. What makes the top of the fraction 0? Well, when x is negative 1. So that means at negative 1, that's our intercept. And we can pretty much kind of sketch what this will look like. Most of the time they look like these. It's approaching that. It's coming up. Oh, we also can get the x-intercept. No, the y-intercept. Sorry, we did get the x-intercept. The y-intercept is when x is 0. So when x is 0, you get 3/2. So that's right here, actually. Or you can get them from your calculator. It's fine. And then when you graph this on your calculator, it should look something like that, and then it comes up from here and goes off to that and never crosses. So that's our graph. Now, here's what the range does. The range is basically all the y values. So pretty much, you look at the top, we have it, there's y values at like 10, 9, 8, 7, 6, 5, 4, 3. You look at this hole. Notice how there is no y value along this spot at this hole. So, for the range, this graph does not cover this y value. This y value is up at 6. So y cannot be 6. So it's the coordinate of the hole. And it's any horizontal asymptotes that it does not cross. Again, the graph does not show up in this region right here for y. That region is y equals -3. So we can't have y equals -3. So that's our range. We get it from the horizontal asymptote sometimes, and we get it from the hole sometimes. There's some cases where that doesn't work. Okay, but that is all you'll need to do. And it's the same process over and over again. Okay? For example, this one. Let's save this one for class. So you guys can skip this. No, you know what? We'll do that later. We'll do this one now. Let's look at this one and see what we have. Let's simplify it first. So we have a hole here. We have a hole here. So right away, I have a hole for part C at 2 comma something and at 4 comma something. I don't know if they are yet. My domain restrictions, I probably should have done that first. I always say to do that first. X cannot be 2, 4, -1, and -5. I just got that from the fact that what makes the bottom 0? All 4 of those things. We used 2 and 4 for the holes. The remaining ones are your vertical asymptotes. So, up here at part A, which is my vertical asymptotes, x equals -1 and x equals -5. So I have all those parts down. Now I look at the y, or the horizontal asymptote. Again, how many x's are on top? If we multiply this out, it'd be x to the 4th over x to the 4th. The degrees match, which means we then look at all the coefficients of the x's. On the top it would be 3. On the bottom it would be, if you multiplied all the x terms out, it'd be a 1. So, the horizontal asymptote is y equals 3 again. Oh, on the other problem it was -3. Now we need to find the holes and graph it. So again, to find the holes, we take this simplified version of our equation and we plug in 2 and 4. So when I plug 2 in, when x equals 2, we get 6 plus 1 is 7. We get 2 plus 3 is 5. 2 plus 1 is 3. And 2 plus 5 is 7. Well, the 7's cross out, and we get 5/3. So you can give this to me in decimal or fraction form, but since fraction is exact, we'll just do 5/3. If you do the other one, with 4, oh, geez. And now we're going to use x equals 4. So when x equals 4, we get 3 times 4 is 12 plus 1 is 13. Again, I'm just plugging it into this simplified form. So 13 times 7 over 4 plus 1 is 5, and then 4 plus 5 is 9. So this is a much bigger number. When you simplify that, you get the decimal 2.022, and those are the 2 holes. So now if I graph this, we have an issue. Not really a big issue, but it's something new. Here's my normal axes. I have a horizontal asymptote at 3. I have a vertical asymptote. Sorry, I keep getting interrupted from other teachers. So, alright, here we go. So anyway, where was I? We were graphing this. We were horizontal asymptote at y equals 3. And we have our vertical asymptotes at x equals -1 right here, and x equals -5. So we have two vertical asymptotes there. We have holes at 2 and 4. So the 2, 1, 2, it's at 5/3. It's a little bit above 1, so there's a hole there. And 3, 4, 2.022 is a little bit higher, about right there. Now, when x is 0, you can really quickly just find out what that value is. You get 1 times 3 over 1 times 5. So 3 over 5. So 3/5. So it's about right here. That's going to hit there. What makes the top 0? It's it's -1/3 and -3. So it's crossing at -3 as well. So here's where we have an issue. If you graph this on the calculator, which we're going to do in class because I don't want to go to the calculator, it'll look something like this, and it might look a little weird. And then it comes up through here, it crosses, and then goes up through here. Now, some of you guys might be like, why did it cross that horizontal asymptote? The horizontal asymptote is for end behavior only, so the ends of the graph, here and here. It can cross the horizontal asymptote in the middle. And then finally it comes back down here and goes through these. There's a hole there, and goes off forever. Now, some of you guys might be saying, okay, the range. It can't be 3, it can't be 5/3, it can't be 2.022, and then that's it. Just like we did before, the y-coordinates of the holes and the horizontal asymptote. However, can it be 3? Isn't the graph crossing the horizontal asymptote here? So now there is a value where y is 3. There's also a value here where y is 5/3, and there's also a value here where y is 2.022. So even though they're open here, do you see how it cuts through there in the middle piece? So because of this middle piece of the graph, y is all real numbers. It can be anything. So we have that one. Alright, now these next three, again, real quick, this is just practice with stating the vertical and horizontal asymptotes and listing the coordinates of all the holes. Again, it's just factoring, figuring out what each piece is and going from there. So let's factor. The bottom you might have to do Batman with, -60. How about 20 and 3? Yep. So if you do Batman or splitting the middle term, you should. I'm gonna just do the guess and check method. You get this: x plus 5 and 4x minus 3. So you get 4x squared minus 3 plus 20, and then minus 15. All right. So right away, cross these out. We have a hole at x equals -5 and something else. We look at the degree on top and bottom. They match. So we have a horizontal asymptote at y equals 1/4. It's the coefficients again because they match. And then vertical asymptotes is what makes the bottom 0 that's not a hole. So we look at this one. Remember, these are both part of the domain. This is a hole. This is now a vertical asymptote. If you set this equal to 0, you get 3/4. X is equal to 3/4. Alright, and then finally, to find the coordinate of the hole, we put -5 into the remaining parts. So we have -5 minus 5 over 4 times -5 minus 3. So we get -10 over -23, or 10/23. And we're done with that part. Again, you guys should probably be able to do these on your own. Real quick, notice how the x values are, there's 3 x's on the bottom, so that'd be like an x cubed. On top, there's like an x squared. So it is bottom heavy, which means that it has more x's on the bottom, which means our horizontal asymptote is y equals 0. That means y equals 0. Anything cross out here? Yes, these cross out. So we have a coordinate of a hole. If you move that over and set this equal to 0, -2/3, and we'll have to find the rest. And our vertical asymptotes are the other two things, are these ones here. Here and here. Alright, so X equals 1/2 and x equals -7. Now we find the whole. This is a little bit more messy. If you just throw it into your calculator, again, it's 2 times -2/3 plus 1 over 2 times -2/3 minus 1 times -2/3 plus 7. That's how you would solve it, and when you plug all that in, you get a decimal of 0.023. Again, for whole, you plug the x value into the simplified form after the whole cancels out. Alright, last one. We're going to look at top, bottom here. We have vertical asymptotes. We don't know yet with the factor. But horizontal. Notice how now it is top heavy. It's an x cubed over an x squared. That means there is none. There are no horizontal asymptotes because of that. Now, let's factor this. Can't factor the top. That's not a sum of cubes. 7 is not a cube of something. And then finally, we have this. We do not have, do we have any holes? Anything canceling out here? I say no, so there are none. Vertical asymptotes are x is equal to 1 and x equals -1, because these are the two values that make the bottom 0. Okay? I know this is a long video, there's a lot in it, so just go through it. This is probably going to be the longest one of this chapter, but it has a lot of important information we're going to reinforce tomorrow. So, and again, a nice little note, a horizontal asymptote only applies to the end behavior or of the function. It can be crossed in the middle, like that problem number 2. Alright, and then we are all done.